Right now, somewhere deep in space, there is an enormous object that looks like it should be becoming a galaxy that contains gas. It appears to be dominated by dark matter. It has the raw ingredients scientists normally associate with the birth of stars. But when NASA's Hubble Space Telescope looked directly into the middle of it, something was missing. There were no stars. And that creates a problem. Because if this object has enough material to build a galaxy, why hasn't it built one? What Hubble found is called Cloud9, and scientists believe it may represent a completely new type of astronomical object. Something left behind from the earliest stages of galaxy formation. But here's where the story gets strange. Hubble didn't simply discover a faint galaxy hiding in the darkness. It may have found something that represents a stage before a galaxy becomes a galaxy. And if that interpretation is correct, Cloud9 could give astronomers a rare look at a process that happened billions of years ago, when the first galaxies were beginning to take shape. So what exactly is Cloud9? Why is it almost completely starless? And how can something this enormous exist without producing the stars that should make it visible? To understand that, we have to go back to one of the biggest mysteries in astronomy: how galaxies are actually born. For decades, scientists have understood galaxy formation as a kind of cosmic construction project. First, enormous structures of dark matter begin gathering under gravity. Dark matter doesn't shine. We can't simply point a telescope at it and photograph it directly, but its gravity affects everything around it. Gas falls into these gravitational structures. The gas becomes compressed, and under the right conditions, some of it collapses into dense regions where stars are eventually born. Those stars begin producing light. Over enormous periods of time, more stars form, galaxies grow, and the universe gradually develops the structure we see today. It's an incredibly complicated process. But there's one problem: scientists don't get to watch the entire process happen from beginning to end. The universe is billions of years old, and even the fastest changes in galaxy formation happen on timescales far beyond a human lifetime. So, astronomers have to reconstruct the story from the evidence that reaches our telescopes. And that is exactly why Cloud9 is so interesting, because it may be giving scientists something incredibly rare: snapshot of an object that appears to have the material needed to form stars, but hasn't done so yet. Cloud-9 was first identified through radio observations because it contains a huge amount of cold hydrogen gas. That gas is important. Hydrogen is one of the fundamental ingredients required to build stars. But when researchers turned to Hubble to search for stars inside the object, they found something unexpected. Nothing. Not a hidden population of stars. Not a dense collection of young stars. Not a normal galaxy glowing from within. Instead, Hubble saw a mostly empty-looking region containing the signatures of gas, surrounded by distant background galaxies. The distinction matters. Cloud-9 isn't simply a galaxy that happens to be very dim. Researchers describe it as a new type of astronomical object, a starless, gas-rich, dark matter cloud that may be a remnant of early galaxy formation. And suddenly, the question changes. We're no longer asking, where are the stars? We're asking, why haven't the stars formed yet? To understand how strange that is, imagine a giant construction site. You have the land. You have the raw materials. You have the structure holding everything together. But after billions of years, you walk into the middle of the site and discover that the building itself doesn't exist. That's roughly the mystery Cloud9 presents. The object has gas. Its environment indicates the influence of dark matter. But the stars that should normally emerge from that material are missing. And dark matter makes this even more fascinating. Scientists cannot see dark matter directly because it doesn't interact with light in the way ordinary matter does. Instead, astronomers infer its presence through gravity. It is one of the reasons galaxies can hold together the way they do. So Cloud9 may be showing us a structure where dark matter and gas have gathered together, but the process that normally turns that gas into stars has somehow stalled. And that could be incredibly important because perhaps Cloud9 isn't a failed galaxy. Perhaps it is a galaxy before the galaxy. But there is an even bigger question. If Cloud9 really is a remnant from the early stages of galaxy formation, then objects like it may have been far more common in the young universe. We just didn't have the technology to see them. Think about what that means. For most of human history, the universe looked like a collection of stars, planets, and glowing galaxies. But telescopes only show us the parts of the universe that produce enough detectable light. There could have been enormous structures that were almost invisible simply because they had not yet turned their gas into stars. And if those objects existed in large numbers, they could change the way scientists reconstruct the early universe. Cloud9 therefore isn't interesting simply because it is strange. It's interesting because it may represent a missing piece of the process that transformed a dark, young universe into the enormous cosmic web we see today. And now comes the part that makes this discovery even more important. Scientists don't yet know exactly why Cloud9 hasn't formed stars. One possibility is that the gas is being kept from collapsing by physical conditions inside or around the cloud. Another possibility is that the object represents a very early or unusual stage in the formation of a galaxy. The evidence is still being studied, and that's important because this is where science becomes different from a science fiction story. Scientists don't get to simply look at Cloud9 and announce the answer. They have to test competing explanations. They need more observations. They need to understand its gas, its environment, its dark matter structure, and whether similar objects exist elsewhere. And that search is already expanding, because Cloud9 may not be alone. In 2026, astronomers also demonstrated how powerful Hubble's enormous archive can be when combined with modern analysis. Researchers used an artificial intelligence-assisted method to examine nearly 100 million small image cutouts from the Hubble Legacy Archive. In only about 2.5 days, the system identified more than 1,300 unusual objects, including more than 800 that had never previously been documented in scientific literature. Many turned out to involve galaxy mergers or unusual galaxy structures. But the bigger point is what this means for astronomy. Hubble has been watching the universe for more than 3 decades, and scientists may still be discovering things hidden inside observations that were already sitting in its archive. So Cloud9 may be part of a much larger story. The universe may contain more unusual structures than astronomers have been able to recognize, and now they have new tools for finding them. But why should anyone on Earth care about a strange cloud, thousands or millions of light years away? Because every galaxy around us is part of the same cosmic history. The Milky Way didn't simply appear fully formed, it developed through enormous amounts of time. Stars were born, gas moved, galaxies collided and merged. Dark matter shaped the gravitational framework around them, and eventually, inside one ordinary galaxy, a small planet developed life capable of looking back into space and asking how all of it began. Cloud9 could help scientists understand one part of that chain, that it may show us what some structures looked like before they became the galaxies we recognize today, and that makes this tiny patch of faint cosmic light much more important than it first appears. But there is still a major problem. Hubble can tell us what Cloud9 looks like. It can reveal the absence of stars. It can help scientists study its environment, but it cannot simply tell us what happened inside that cloud billions of years ago. That requires more evidence. And this is where the next generation of observations becomes important. NASA's James Webb Space Telescope can observe the universe in infrared wavelengths and is designed to study faint and distant objects that Hubble cannot fully characterize. Other observatories can study gas, X-rays, radio emissions, and gravitational effects. The goal isn't just to look at Cloud9 again. The goal is to find out whether Cloud9 belongs to a much larger population of objects. Because one strange object is interesting, but hundreds of them could change the story. And there's another possibility. What if Cloud9 isn't an unfinished galaxy at all? What if it's something that has survived from a very early stage of cosmic evolution? NASA describes it as a possible relic or remnant of early galaxy formation, meaning we could be looking at a structure that preserved information from an era when the universe was still assembling its first large-scale structures. If so, then Hubble hasn't simply photographed an unusual object, that it may have opened a window into a stage of galaxy formation that has been extremely difficult to observe directly, a stage where the ingredients are present, but the final structure hasn't arrived yet, and that is why Cloud9 matters. The strange thing about the universe is that sometimes the most important discoveries aren't the brightest objects. Sometimes, they're the things that almost disappear into the darkness. Cloud9 is faint. It doesn't look like a spectacular galaxy. It doesn't have billions of stars lighting up the sky. It doesn't look like the cosmic cities that fill Hubble's most famous images. And yet that emptiness may be exactly what makes it valuable, because the absence of stars is itself information, that it tells scientists that something about the normal process of galaxy formation may be missing from the picture. And until they understand why, Cloud9 remains a cosmic question mark. Hubble has spent decades showing humanity a universe filled with galaxies. But now, one of its most interesting discoveries may be something that isn't a galaxy yet, a massive cloud, cold gas, dark matter, almost no stars. And a question that reaches all the way back to the earliest chapters of cosmic history. How does a galaxy actually begin? Maybe the answer isn't found by looking at the brightest galaxies in the universe. Maybe it's hidden inside the darkest ones, and maybe Cloud9 is giving us a glimpse of the moment. Before the lights came on, the universe is still full of places we haven't understood. And somewhere inside that darkness, there may be more Cloud9 South waiting to be found. Hubble has already shown us one. Next question is, how many more are hiding out there? If you want more stories about the discoveries happening at the edge of what humanity understands, subscribe and turn on notifications. And tell me in the comments.